Hello students, welcome to my channel. Today in this video we are going to start a new chapter, that is chapter 6, study of first element hydrogen of class 9 chemistry. So students, why we are going to start this chapter? Why hydrogen is so important? First of all, it is the first element of the periodic table. In the last chapter, we have studied about periodic table, and in periodic table, the first element is hydrogen. Now, hydrogen is why it's so much important that we have one entire chapter is dedicated to this element. The reason is that it is quite unique in its nature, in its properties. So, to understand, we have to understand that why hydrogen is so unique. So first thing, it is unique because of its position in the periodic table. So let us understand what is the position of hydrogen in periodic table. So as we know that in a periodic table there are some columns, right, and there are some rows, and those rows are called as periods and the columns are called as groups, isn't it? So let us assume that it is group 1, it is group 2. Similarly, at last there will be group 18 and then group 17. Now the columns are groups and the rows are periods. So this is period 1, this is period 2, and this is period 3. So now if you see the first period, in the first period there are two elements, that is hydrogen and helium. But hydrogen is also positioned in group 17. Why? Why it is positioned in group 17? So that means hydrogen is having dual nature, and that is why it is positioned in two places. Why it is positioned in two places, that we will understand now. So if you see here, the hydrogen atomic number is 1. So along with hydrogen, what are the elements are there? Along with that, lithium is there, right? Then sodium is there. And here in group 17, who are all there? In group 17, fluorine is there, chlorine is there, right? So now if we see their nature, so hydrogen is having dual nature. So what is it means? Dual nature means what? So dual nature means hydrogen. What is the configuration of hydrogen? So hydrogen is having only one electron in its outermost shell. So configuration is 1. So is it stable? No, it is not stable. So hydrogen can gain one electron. It can lose one electron to form a H plus ion, that is hydrogen ion. That means it is losing electron and it is getting a positive charge. So we can say that hydrogen can form electropositive okay, it is behaving like electropositive element. At the same time, hydrogen can also gain one electron to form what? To form a hydride ion. Form a hydride ion, which is again a electronegative ion. So it is behaving like electronegative element. So you can see hydrogen can lose electron, it can lose electron, and also hydrogen can gain electron. So since it can lose electron and also it can gain electron, to become stable, it is called as dual nature of hydrogen, and that is why it is placed in both the groups. It is positioned in group 1 as well as it is positioned in group 17, because In group 17, who are all the elements? Like fluorine is there. Chlorine is there. If you see the configuration of fluorine, what is the configuration of fluorine? It is 2, 7. Chlorine configuration is 2, 8, 7. That means what? They always lose one electron. So their valency is always what? Their valency is -1. Here also its valency is -1. And here also if you see lithium configuration is how much? 2, 1. Sodium is 2, 8, 1. So here also it is having one electron. So here it will lose the electron, but here it will gain the electron. Remember, in group 17 all the elements gain electrons. How many electron? One electron. But in group 1 they all lose one electron. Now this hydrogen is having both these properties. So they are placed in group 1 as well as in group 17. So you understand why hydrogen is having dual nature? This is the reason. Okay. Now we will see that how we can prepare the hydrogen in laboratory. That is laboratory preparation of hydrogen. So laboratory preparation means here we will learn how we can prepare hydrogen in laboratory without any risk or without any hazard. Hazard means their safety will be the first property when it is prepared in laboratory. But it will be in very small quantity. We will not use any dangerous chemical or any harmful chemical in this preparation. Okay. So in this preparation, for laboratory preparation, we need some apparatus. So what are the apparatus? Let us see. So this is a round bottom flask. It is called as a round bottom flask. Okay. And inside the round bottom flask, one cork will be fitted, and through the cork, two funnels will be passed. The first one is, this is the first funnel, which is known as thistle funnel. This is called as a thistle funnel. This funnel is known as what? It is known as thistle funnel. And another tube will be passed through it. The second tube is known as delivery tube. First let me draw the diagram. So this is our what? Gas collecting chamber, and it will be filled with water. Remember that the gas collecting chamber will be filled with water. Also it will be having a empty gas jar which will be kept in overturned position. Okay, and in that also water will be filled. So in the gas jar, what will be filled? Water will be filled, and the delivery tube will be fitted inside that gas collecting jar. This is our delivery tube, and through this tube hydrogen gas will be reached in the gas jar and it will be getting collected. Now in the round bottom flask we will take some chemicals. So what are the chemicals we will take? So we will take here zinc granules. So all these are what? These are zinc granules. Now through the thistle funnel, either dilute sulfuric acid or dilute HCl will be poured. So through this what will be poured? So through this dilute sulfuric acid or dilute HCl will be poured. Okay, this is what dilute HCl. So first zinc granules are taken in the round bottom flask, then the cork is fitted. This is the cork. Okay, the cork is fitted, and through the cork what is kept? Thistle funnel is inserted, and a delivery tube is also inserted. This is called as delivery tube. And this is our gas jar, and this is the laboratory preparation of hydrogen gas. So it's very simple. First zinc granules is taken, then dilute HCl is poured through the thistle funnel, and we have to remember that the thistle funnel, the tube should be dipped inside the liquid, inside the dilute HCl. Otherwise what will happen? The gas will escape through the thistle funnel. To prevent the escape of gas through the thistle funnel, the thistle funnel is dipped into the HCl, and the delivery tube is kept somewhat at the upper part, so that the gas can pass through the delivery tube only, and gradually the hydrogen gas will be collected inside the gas jar. Is it clear? So now let us see what reaction takes place. So when zinc react with dilute HCl, so when zinc react with dilute hydrochloric acid, then what happens? Here displacement reaction takes place, and the zinc displaces the hydrogen, and it forms what? It forms zinc chloride plus hydrogen gas. So hydrogen gas is formed here, and this hydrogen gas is collected in this gas jar. Okay, so now this is the main method. So we can you have understood how we can prepare the. Now we have to remember that the gas, hydrogen gas, is collected by downward displacement of water. Now what is this? What is downward displacement of water? So downward displacement of water means that the gas is very light. It is lighter than air. So whenever the hydrogen gas is formed, it always escapes. To prevent that escape to the air, we dipped the delivery tube into the water filled gas jar. So now when hydrogen gas will form, they will go and they will get collected here. So all the hydrogen gas will be collected here, and water will be displaced downward. So it is written the downward displacement of water. Is it clear now? Okay. So now we will see that how we can prepare the hydrogen gas in industry, means in large quantity. Laboratory means in small quantity, and industry means large quantity. Preparation of hydrogen in industry, or it is also known as industrial preparation of hydrogen. Okay, so in industry it is prepared by a process called as Bosch process. Okay, this process is generally used in industry. So we will understand now Bosch process, that is the process of preparation of hydrogen in industry. So for this it is divided into several steps. So first we will understand the first step. In step 1 what happens? Production of water gas takes place. So what is water gas? Let us understand. Water gas is nothing but mixture of carbon monoxide and hydrogen. That mixture is called as water gas. So how it is done? Very simple. Coke and it is not that Coke Pepsi which you drink. It is Coke means the partially heated coal is called as coke. Okay, when the coal is heated, then it forms coke. It is reacted with hot steam at 1000 degrees Celsius, very high temperature. So the pressure will be very high, and at that pressure and temperature this reaction takes place, and what happens? Carbon monoxide is formed and hydrogen gas is formed, and mixture of these two is called as water gas. Remember that. So when coke and hot steam is reacted in at 1000 degrees Celsius, then carbon monoxide and hydrogen combine to form water gas. Okay. So now here the coke which is taken is red hot coke. Remember that red hot coke is taken. Okay. Next, step 2. So what happens in step 2? In step 2, reduction of steam to hydrogen takes place. So reduction of steam to hydrogen by carbon monoxide. This is the step 2. So in step 2 what happens? That carbon monoxide and hydrogen, they react in presence of water. Okay, that is the water gas react in presence of excess steam at 450 degrees Celsius. Remember, these conditions are very important, so you have to write. And one catalyst is used, that is ferric oxide. So ferric oxide act as a catalyst, and at 450 degrees Celsius this reaction takes place, in which the carbon combines with oxygen and form carbon dioxide. So carbon monoxide reduces the steam. Okay, so reduction of steam to hydrogen, that means reduction means here removal of oxygen. So you see, from water oxygen is removed by carbon monoxide and it forms carbon dioxide. Yes, this oxygen is taken away by carbon monoxide and it forms what? Carbon dioxide. And what is remaining now? Only hydrogen is remaining. So it will be remaining hydrogen. Now we will balance it. So here you see 2 hydrogen, 2 plus 2, 4 hydrogen is there. So here also we will write 2. So now 2 into 2, 4 hydrogen. So now it is balanced. Okay. So this is called as reduction. Reduction means removal of oxygen. Who is getting reduced? Water is getting reduced. How? Because its oxygen is removed. By whom? By carbon monoxide. So carbon monoxide takes one oxygen and forms carbon dioxide. That is why it is called reduction of steam to hydrogen. That means steam is forming into hydrogen. By whom? By carbon monoxide. Clear? So remember here that CO is nothing but carbon monoxide. So now in the step 3 what happened? So we have to remember that along with Fe2O3 also chromium oxide is also used. Okay, chromium oxide or chromic oxide is used as a promoter. Already you have discussed what is a catalyst. So this is a catalyst and this is a promoter. Remember that. Next we will see step 3. So in step 3 what happened? We have to separate now, because you see carbon dioxide and hydrogen is mixed. So you have to separate the carbon dioxide and unreacted carbon monoxide from the above mixture. Okay, so because we want hydrogen, we don't want carbon dioxide or carbon monoxide. It is the industrial preparation of hydrogen, so you have to remove the hydrogen from it. So how to do? So carbon dioxide is removed by dissolving the gas mixture in water or caustic potash solution. So what happens? So suppose this is KOH is the, let us see the reaction. So KOH is caustic potash solution. When it reacts with carbon dioxide, what happens? It converts, it forms potassium carbonate plus water. That means carbon dioxide is taken away by potassium hydroxide, which is nothing but caustic potash solution. Okay. Now we'll see how carbon monoxide is removed. So carbon monoxide is removed by dissolving the gas mixture. What is that gas mixture? Mixture of hydrogen and what? And carbon dioxide. That mixture we will dissolve in the ammonical cuprous chloride solution. Ammonical cuprous chloride solution. So what happens in this reaction? Let us see. So CuCl is cuprous chloride. When it reacts with carbon monoxide, remember capital C, capital O is carbon monoxide. If you give small o, then it is wrong. In presence of water, it forms what? It forms a complex substance, and by this the carbon monoxide is removed. So this is the industrial method of preparation of hydrogen, which is also known as Bosch process. Okay, we'll stop here and we'll continue in the next class. Till then, have a great day. Bye bye. And if you like the video, then like it, share my video with other students and subscribe my channel. Please subscribe the channel so that you get the notification of the next video. Thank you.